Moving right along here, practice exam 5, problems 22 through 30. These will go a little bit faster here. Some of these are very basic questions. Number 22 here is asking us here if the C4 alcohol reacts with a carbonyl right here. You should know that the one position is the carbonyl carbon, and then we go here, here's the 4 position. Right there, that's how we number it. So it's asking if this wraps around and attacks right there, what usually forms? It forms a hemiacetal. There, by definition, ketols would come from a ketone, and this is an aldehyde, so C and D are both out there. Okay, 23, I actually don't like this one as much here. Well, it's not too bad, but anomers here means alpha and beta right here. So it's asking you to compare the alpha and beta. So one thing we want to make sure of here is that we have the right sugars here. And this is the reason I don't like this one, is because I accidentally, I believe, messed this one up. Let me see here. No. So aldo means we have an aldehyde, and that is a ketose right here. See the CH2 hanging off right there? That CH2 indicates we have a keto right here. Ketose, same thing right here. We have a keto right here. So these two are not even the correct definition. Right here we have an aldo, and let me make sure this is a pentose. 1, 2, 3, 4, 5. Yep, that's a pentose. 1, 2, 3, 4, 5. And the problem with this was actually discard. The OH should be down here, not up here. Right. But if that OH was correct, 1 and 3 would have been the answer choice right there. But a couple definitions given there: alpha and beta anomers are called anomers of each other, and then we have aldo, which means comes from an aldehyde, and pentose, which means 5. Next one here, a little bit simpler. We have a ketohexose. Here we need a ketone, so that one's out. That's a hemiacetal there. So A, C, and D are the only possibilities, and this is asking for a hexose, which is 6 carbons. So here we have 1, 2, 3, 4, 5, 6. That one is the ketohexose right there. The others you'll find will have too little or too less carbon. Excuse me. Okay, on problems like this, it's not asking you to correctly identify all of the OHs and where they are, though you may have to do that in biochem. This is asking you to focus right here in that part of the name. We need a D sugar, and we need the alpha of the D sugar. So C is out. This is an L sugar because the CH2 is down, and L sugar because the CH2 is down here. And so the choice is between B and D now, and alpha means that the CH2 and the OH are opposite, or the OH is down in a D sugar. There's the answer. Here again, number 1 position is the anomeric position right here, and we want the OH to be opposite, hence the crisscross right there is how I had people memorizing that. Oops, crisscross like that. And it also means in a D sugar the OH is pointed down, and it's just the opposite for an L sugar. Number 26 here, ketose means from a ketone. It's that is not a ketone right there, that's an aldehyde. This is a hemiacetal. So hemiacetal means that came from a aldehyde right there, so that's out. Right here. Now this is in D. This is the acetyl version of an aldehyde right here, not a hemiacetyl. That is an acetyl group. Right here, let me circle it. There's the acetyl group. So that leaves, that's wrong, that leaves A as the answer choice here, and you see that this CH2 makes that a ketone, ketose, right there. Okay, number 27, right here. This is asking, is this a D or L sugar, which looks easy, but when we go here to this part of the molecule where we should find a CH2 pointed up or down, there's no CH2. Well, by definition then, we have to go to the last stereocenter in this molecule, which is this one, to determine if it's a D or L sugar. Let me draw this molecule now in linear form so you can see it a little bit better. There's that part of the molecule right here, and then we have 1, 2, 3 stereocenters right here, and then we have a little CH2 hanging off OH. That is the OH that came around and wrapped around to attack right there. So here we have carbon number 1, 2, 3, 4, 5, 6. Let me label this 1, 2, 3, 4, 5, and 6. Right there. Down, remember, means to the right. So we have 3, we have a down, down, 4. 5 is also down, right there, and their answer is now more apparent since the last stereocenter is pointed to the right. That is a D sugar right there, and we have to have the correct reason why when we look through this. Of course, C is out, it's not a L sugar. Here we have to have a D sugar because C5 is down, which also means C5 is to the right. D is the correct answer. Number 28, pentose means 5, sugar with 5 carbons. Next one, 29, how many stereoisomers exist for this monosaccharide in this form? I don't really like it that I've asked it in this way, but here we have to count all the stereocenters present in this molecule. Here we have 1, 2, 3, 4, 5, and you see we have 2 to the 5, which means 2 times 2 times 2 times 2 times 2, and we can do this here 4 and 8 and 16, and we multiply that, that is 32 right there. Answer is 32. Okay, that one had a lot of stereocenters in there. Okay, the last one here, now this is asking you to correctly make a Haworth projection here for number 30. And here, when we make the projection here, we have to look, this is kind of odd, this is a L sugar right here, and so A and B are out. It's kind of odd that I did this, I probably won't do it again, but L sugars are not naturally occurring. Here we have an L sugar, and let me count this now, 1, 2, 3, 4, 5, 6. We want to make sure that we have the alpha form of this right here, and alpha means the crisscross of this. So this one is opposite of that. Oh, this one is also opposite of that. Let's go to the next one then. Here we have left and left on that one, which should mean up and up, up, up. C is the answer on that one. We can also look, this one is down, that one is the C4 position, and let me label that we go. And there is through 30.